We were doing word problems and we go further on the word problems where we are going to with two more samples of word problems today. We are going to deal with problems related to mensuration. Mensuration means area, perimeter, and so on. That means anything related to shape. And we are going to also deal with another set of problem which relates to boat and stream. When we go to this topic, we'll talk more about it. So let's first take on with area and perimeter. So let's look at this question. Half the perimeter of a rectangular garden whose length is 4 meters more than its width is 36 meters. Find the dimensions of the garden. So when it's talking about rectangular, of course, we need to find the dimensions as length and breadth of the garden. This particular sentence that begins from half and ends at 36 meters is a complex sentence. So I'm breaking this sentence into two parts. Please observe. Look at now only the underlined portion. It says half the perimeter of a rectangular garden is 36 meters. So this is the main clause of the complex sentence, wherein this is the subordinate clause which has not been underlined. So first I'm interpreting only the main clause. So if we assume the length and breadth to be L and B respectively, using the formula for the perimeter of a rectangular, we know that half means 1 by 2, perimeter means twice L plus twice B, and it is equal to 36 meters. Is means equal to, and 36 will come after equal to. In this equation, we can see that we have a bracket which has 2L and 2B. So it can be divided by 2 and this can be simplified. Now it says length is 4 meters more, which means plus 4. Never write 4 plus, it's always plus 4. Its width, and we've assumed the width to be b. So this is the second equation. The first equation can be rewritten as L plus B equal to 36 by after dividing by 2. So equation number 1, equation number 2, we can solve them using any of the methods: elimination, substitution, or cross multiplication, and thus get the dimensions of the garden. Let's look at another question, which is an application of mensuration, that means area of a rectangle. The first one was about perimeter. Now we are going to area of rectangle. The formula for area of rectangle is length into breadth. Again, we are assuming the length to be L and breadth to be B. Now, if the length is L and the breadth is B, the area becomes L into B. L into B. However, it says it is getting reduced by. Now, the mathematical meaning of the English gets reduced by is not just equal to, but it is equal to, and something is getting subtracted. So it is getting reduced by 9 square units. 9 square units. And when does that happen? If the length is reduced by 5, so there is an if condition. So the length is reduced by 5 and the area is getting reduced. So subtraction of 9 from what? The area of the rectangle. The length is reduced by 5 and the breadth is increased by 3 units. Now this becomes an algebraic expression, the product of a binomial here and a binomial here, where L and B are the variables. So we multiply them and we get this. Once we get this, we can see that there is an LB and LB on both the sides, which can get cancelled to each other. So the equation stays as this much, which is the first equation. For the second equation now, we are going to interpret exactly in the same manner as we interpreted the first equation. So now, if we increase the length by 3, that means the length becomes L plus 3, and the breadth by 2. So the breadth plus 2, then the area increases by 67, and the initial area is LB. It increases by, so the interpretation of increases by is, that means it is equal to and plus here 67 units. Again, we open up the product of this binomial, it becomes this much. LB and LB on both the sides get eliminated. So we are left with this equation. So equation number 1 and equation number 2 are in the variables L and B. They can be solved and we get the dimensions or the length and breadth of the rectangle whose problem about area was given to us. So these were direct applications of mensuration, the direct applications of mensuration. So we had, we are again going back to where we wanted to cover the two learning outcomes for today, which is mensuration and boat and stream. We've done a couple of questions where we saw how does mensuration direct questions appear. So now if we want to see that what does the application of mensuration would look like. So let's talk about application of mensuration now. The students of class are made to stand in rows. Now, when any arrangement takes form of a grid, a row and a column format, it is always an application of rectangle. And if the rectangle appears, then either the area or the perimeter will come. However, this arrangement is about the area of a rectangle. So, we are saying let the number of rows be R and then let the number of columns be C. So, rows means 3 students are extra in a row, implies that 3 students have increased in a column. So, column has become C plus 3, right? So, children have increased in a particular row means columns have increased. And there would be one row less. So, the rows will decrease because the number of students have increased. However, if 3 students are less in a row, that means the columns have decreased by 3, there would be 2 more rows. So the rows have increased by 2. But the total number of students will stay as row into column in both the cases. So the number of students in case 1 and case 2 is R into C, that is row into column. Again, there is a binomial product here. We open this, cancel RC on both the sides, and the equation stays as 3R minus C minus 3 equal to 0, minus 3R plus 2C minus 6 equal to 0. It can be solved for RC. Our final answer will not be R and C, but it will be the product of R and C, because we need to find out how many total students are there in the class, which is number of row into number of column. So whatever value for R we get and whatever value for C we will get, will multiply those two values, and that will be the final answer. Now, the, we are coming to now the boat and stream problem. What is a boat and stream problem? Let's look at this. If there is no movement of the water, then the boat will move at the speed defined by its engine. So if the engine speed is x kilometer per hour, that will be the speed of the boat because the water is not making any movement. However, the water itself the water itself can have its own speed. So the water itself has its own speed, right? So, and it has its own direction as well. So, let us say the water is moving in this particular direction, and the boat is also moving in the direction of the water. In that case, the direction of the water helps the speed of the boat to move further. Hence, the resultant speed will be x plus y kilometer per hour, and this is known as downstream speed. And this kind of a movement, when both are moving in the same direction, is known as downstream speed. Now let's take the reverse case. The water is moving in this direction, but the boat is moving in opposite direction. So the water is in this direction and the boat is in opposite direction. And remember please, the individual speed of boat is x, the individual speed of water is y. Now, because the boat has to go against the flow of the water, therefore, the resultant speed will be the speed of the boat minus the speed of the water. This kind of a movement is known as upstream movement, and this speed is known as upstream speed. So, whenever there is a movement of boat in a water, there are two types of movement that takes place: downstream and upstream. Each will have a different kind of a speed as a resultant speed of the boat and stream together. Let us do a couple of questions based on this. Ritu can row downstream 20 kilometer in 2 hours. So let's look at a simple formula of speed is equal to distance upon time. If we are assuming that the speed of the uh, rowing is x kilometer per hour, now rowing is as good as the speed of the boat, and speed of the current is the speed of the water, which is y. So downstream speed is x plus y, upstream speed is x minus y. Distance for downstream is 20 kilometers. Time for downstream is 2 hours. Distance for upstream is 4 kilometer. Time for upstream is 2 hours. And if we apply this formula, speed is equal to distance upon time, then speed, that is x plus y, is equal to distance, that is 20 upon 2. And for the second equation, speed is x minus y, distance is 4, time is 2. So we've simply applied the formula speed is equal to distance upon time. And these two equations can be solved, and x will give us the speed of the rowing, which is as good as speed of the boat. Y will give us the speed of the water, which is as good as the speed of the current. Let's look at one more example. Now over here, let the boat, speed of the boat in still water means when there is no hindrance from the water, is x kilometer per hour, and speed of the stream be y kilometer per hour. Now the downstream speed therefore will become x plus y kilometer per hour, and upstream will become x minus y. Upstream is always the lesser speed because it is against the current. Now, the boat goes 30 kilometer upstream, and we are using the formula time is equal to distance upon speed. So, the distance traveled is 30, speed is upstream speed, and means plus 44 kilometer downstream speed. That means 44 kilometer is the distance. Speed for downstream is x plus y. Total time, this is the time taken for upstream movement, this is the time taken for downstream movement. Please remember, we took distance upon speed, and the total time is 10 hours. So we have an equation which we will have to reduce. This is a reducible kind of equation. We will take 1 upon x minus y is equal to u, 1 upon x plus y is equal to v, and then solve. Let's look at the second part of the statement. 13 hours is the total time. 40 kilometer is the upstream distance. So distance by speed. So it will become 40 upon x minus y. 40 is the distance for upstream. X minus y is the speed for upstream, plus 55 kilometer downstream. So 55 is the distance for downstream. X plus y is the speed for downstream. Hence, total time for upstream is 40 upon x minus y. Time for downstream is 55 upon x plus y. And the total time taken together in case 2 is 13 hours. So we've got the second equation. We have covered the problems for mensuration and boat and stream in today's module. Thank you.